Okay, we're in chapter 24, which has to do with integration. So chapter 24.1 is has some rules, 24-1. And if I want the integral of x to the n, then that's going to be x to the n plus 1 divided by n plus 1 plus some constant of integration c, but n can never be minus 1. So if n were minus 1, I'd be dividing by 0. That'd be bad. If I have the integral of two functions, f of x, g of x, then I can divide them up and do them one at a time. Function integral f of x plus the integral of g of x. So I can do that. And if I have the integral of some constant, then that's the same as the constant times the integral of f of x. And these rules are the same as what you'd use for summation things. And I guess that's enough rules. Okay, so now I'm looking at problems, and I'm looking at problem number 4. And I want the integral of 200 x to the 9th that doesn't look like a 9 dx. So I'd say, well, that's going to be 200 x to the 10th divided by 10 plus some constant c, and for my final answer I'd say it's 20 x to the 10th plus some constant of integration c. I could check my work and take the derivative of that. So if I take the derivative of this, I get 200 x to the 9th, and the constant goes away, and that is the problem I had. So that works just fine. I'm going to look at problem number 24. 24. Okay, number 24, we got the integral of x to the 4th, x to the 5th plus 3 raised to the 7th. And what we would do is we'd make a guess. And I'm guessing that the answer is going to be x to the 5th plus 3 raised to the 7th, raised to the 8th. Now, when I take the derivative, I'm going to have to divide by 8. When I take the derivative of the outside, I'm going to have a 5x to the 4th, so I'm going to have to divide by a 5. So my guess is going to be x to the 5th plus 3 raised to the 8th divided by 40. Okay, now I'm going to take the derivative of my guess and see what it is. And I'm going to have 8 x to the 5th plus 3 raised to the 7th times 5x to the 4th divided by 40. The 8 goes away, the 5 goes away, the 40 goes away, and I have x to the 4th. I have exactly what I'm looking for. So my integral becomes x to the 5th plus 3 raised to the 8th over 40 plus some constant of integration c. But I do a problem like that by coming up with a guess. And the guess would be an educated type guess. Number 48. Okay, so I've got the integral. Now your TI 36 Pros do these for you. We'll go back. I'm going to go back to the other guy. Maybe I'll go back to the other guy. I'll go back to this guy and put it in my calculator and see if I get the same answer. So I'm taking my calculator, and I can't get the same answer because it has to have numbers. It won't do an indefinite integral. So yeah, yours will, but mine won't. Alright, so number 48, 60 x cubed plus 36x divided by the fourth root of, who made up this problem anyway? Fourth root of 5x to the fourth plus 6x squared. Oh, fourth root of that. 36 goes into there. 6 goes into there. X goes into there. Okay, I guess we'll have to guess. So I'm going to do a guess, and I'm going to say this is to the minus 1/4, right? So if I had 5x to the fourth plus 6x squared raised to the 3/4, and I subtracted 1 from that, I would have 1/4. Okay, so that's going to be my guess. And now I'm going to take the derivative of my guess. And I have 3/4, 5x to the fourth, 6x squared raised to the minus 1/4. The derivative of the inside, 20x cubed plus 12x. Okay, so what am I going to do with that? Other than reposition it so I can see it better. Okay, so I've got 3/4, 5x to the fourth plus 6x squared divided by the fourth root of 20x cubed plus 12x. Okay, now in my radical, I want a 5x to the fourth minus. Now, how did that? What did I do? Where's the undo button? Oh, there we go. Undo, 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 undo. All right, do it again. Okay, so I've got that. I've got 20x cubed plus 12x divided by the fourth root of 5x to the fourth plus 6x squared. Okay, so I need up here 3 times. So there's my 3 times. So if I do that, I end up with a 60x to the cube plus 36x. Now I've got this quarter to deal with, so I need a quarter right there, and I need to multiply it times 4 so that I multiply it times 1. And now I'm ready to write down the final answer. So the final answer is going to be 4 times whatever my guess was. 5x to the fourth plus 6x squared cubed the fourth root of. And that and with that I can get rid of my parentheses because I don't need them anymore. Because just 4 times that will make this 4 bigger. Okay, is that all right? Not doing anything funny there. Now 24. We're 24-2. We're just doing the same thing over again. So we'll just go do the same thing over again. 1 through 18, well, 18 to 22, and 18 to 22 are the electronics problems. So that's why we're doing them. So we're in section 24.2, starting with problem 18. The power in a system equals the rate at which energy, which is work, is expended. That is, power is equal to change in work, change in time. So power, change in work, change in time. At 0, the energy in the electrical system is 4 joules. Okay, so W at 4, W at 0. W at 0 is 4. W at 0 is 4 joules. Find the energy after 4 seconds if power is 2 the square root of T watts. Okay, so power is 2 the square root of T, which is also dW dt. So dW is 2t to the 1/2 dt. I integrate both sides, and I get W at t is equal to 2t to the add 1, 3/2 divided by 3/2 plus some constant of integration. We know that W at 0 is 4. So W at 0 is 4, which is going to be C, implying very strongly that C is equal to 4. See, when I put a 0 in here for the T, this whole thing becomes 0. So now my final answer would be W at T is equal to, I'm going to invert and multiply 4/3 T to the 3/2 plus 4. Now, that was 18, right?
Go back up.
How far? Okay, good enough? I was going to say we look in the back of the book and see if I got it right, but there's only the odd ones in the back of the book, so we're not going to do that. Okay, we're looking at problem number 19. 19 says, a capacitor with capacitance 100 microfarads is the way we would write it, right? We wouldn't write 10 to the minus 4th. That'd be a silly thing to be writing. Has a voltage of 100 volts across it. So I have 100 volts across the capacitor. At a given time t, the capacitor is connected to a source that sends current. Okay, so I've got a current source. How do I make a current source? I forget. That's not how I make a current source. I'll just do it this way. Current source. And that current source is 1/2 the square root of t plus 0.2. 1/2 square root of t plus 0.2. No? Oh, just with an A in it?
Current, yeah.
Through the circuit. Find the voltage across the capacitor at t equals 0.68 seconds. Alright, so I got this circuit. It's like that.
Circuit won't work. No ground.
No, it doesn't work in Multisim, but it works for me.
Yeah.
The voltage across the capacitor is dq dt, right? What's the voltage across the capacitor? The voltage across the capacitor is Q is it V over, no, what is? Oh, bummer. What is the voltage across the capacitor? Q over C, right? Q over C, charge over capacitance, is the voltage across the capacitor. Okay, and charge di dt, change in current, change in time? No. Current is change in Q, change in time. The change of charge. Okay. All right. I got that. All right, so I think I got that one right. So that means change Q, change in time, is going to be equal to 1/2 the square root of t plus 0.2. dq dt is, no, dq, no dt, is equal to 1/2 square root of t plus 0.2 dt. I'm separating variables, that's what I'm doing there. I'm integrating both sides. And I have q at t is equal to what? Q at t, okay, so this would be 1/2 t to the 3/2 divided by 3/2 plus 0.2 t plus some constant of integration c. Okay, and so q at times t would be 4/3 t to the 3/2 plus 0.2 t. Now, plus c. Okay. Now, what is C? V is equal to Q over C. This C is different than that C, naturally. We'll change this to a K, because this is a constant of integration, not the capacitance. So I've got Q is going to be 100 times 10 to the minus 4th, which is 10 to the minus 2nd. So Q at 0 is 10 to the minus 2nd. So Q of t is going to be 4/3 t to the 3/2 plus 0.2 t plus 10 to the minus 2. Now we're supposed to find the voltage across the capacitor at time t, right? Okay, so Q at 0.16, 4/3, 0.16, 3 halves plus 0.2, 0.16 plus 0.01. The square root is 0.4. 0.4 cubed is 0.064 plus 0.2, that'd be 0.03632 plus 0.01. Did I do that right? I think it's time to take out my calculator because 3 doesn't go into, no, 3 goes into 64. Well, I don't need my calculator yet. 3 goes into 64. 0.0, no it doesn't. No it doesn't. Okay, take out my calculator. 4 thirds times 0.064 plus 0.032 plus 0.01. Syntax error. Point 0.13. 0.13 coulombs. The voltage is going to be 0.13 coulombs divided by 10 to the minus 4, which would be 1,300 volts. So at this point, somebody should look in the back of the book and tell me that I'm right. Well, you can just tell me that I'm right. You don't have to look in the back of the book. Yes, this is a capacitor with 100 volts on it already, and I'm throwing a shit pot of charge onto it. Even though it's 160 milliseconds. Who asked you?
You did, actually. It's supposed to be 633 volts.
Well, that's pretty close.
But I got 640.
Yeah. So I was doing too much of the arithmetic in my head probably. And if I go back, should we go back or should we go on?
It's good.
So if I go back to, that's 10 to the minus 2. That's there. Okay, let's look at 0.16. 0.16 raised to the 3 halves. Mode. I only have, I got my mode set at 2 decimal points. And so that was correct, 0.604. Now there's nothing saying that the book is correct. You know, when you come right down to it, right? Times 4 thirds plus 0.2 times 0.16 plus 0.01 equals. So I get, this guy becomes a 0.1273. And even at that, I get I still, when divided by 10 to the minus 4th, I still get 12,000. So I'm 1,200. I would say that my answer is probably right and the book is wrong, and we'll go on. What do you think about that? Our other choice is to start with the problem from scratch. You want to do that?
No.
No, I didn't think so. All right. Just wondered. What was that, 19? 20. I'm pretty sure that last time I got that same answer, and the back of the book still said, maybe my back of the book says something different because I changed it. No, I won't bother to look. 20. A 0.1 farad capacitor with 150 volts across it. That is one big capacitor, isn't it? 0.1 farad, 150 volts. So that'd be an industrial guy sitting in an industrial setting type of capacitor. At T0, the capacitor connected to a source. So I of T, 16 T divided by the square root of 4T squared plus. I wonder where they're getting these sources from. Amps through the circuit. Find the voltage across the capacitor in 2 seconds. Okay, so first thing we have to do is find out what is the charge on the capacitor at time 0. T equals 0. Charge is going to be voltage times that, so it'd be 15 coulombs on the capacitor at time 0. Okay. dI dq dt is equal to the current. dq is equal to 16t divided by the square root of 4t squared plus 9 dt. I'm going to integrate both sides, and I'm going to get the charge at t is equal to something. Okay, so I'm gonna leave enough room here so that after my guess I can fill in what I need. Interval. Okay, so I'm gonna do a guess. I'm gonna guess I'm 4t squared plus 9 to the 1/2. G prime would be 1/2 times 16t squared divided by the square root of 4t squared plus 9. So I need a 1/2 here, and I need a 2 out there. And when I get done doing that, I'm going to say that this is going to be 2 times the square root of 4t squared plus 9 plus some constant c. Now, Q at time 0 has to be 15 coulombs. And so that would have to be 2 the square root of 9 plus c. So 2 the square root of 9 would be 6. 6 divided by that. So we're going to make this k, constant of integration k, so it's not confusing. And so k would have to be, this is 6, so k would have to be 9. So Q at times t has to be 2 the square root of 4t squared plus 9 plus 9. Q after 2 seconds, which is what we're trying to do. Q after 2 seconds, 2 square root of 16 plus 9 is 25 plus 9 is going to be 19 coulombs. The voltage is going to be 19 coulombs divided by 0.1 farad, or 190 volts. Okay. Someone tell me that I got that one right. Oh, you can't because it's even. Good. Well, I'll just tell myself I got it right. Okay, good enough? That seemed easier than the last one for some reason. I don't know why. Alright, 21. So 21, a circuit, a current in the capacitor is I of t is equal to t the square root of t squared plus 1. All right. find the charge in coulombs that pass through a given point in the circuit after 1 second. Okay, Q at 0 is 0. Okay, dq dt is equal to I. So dq is equal to t, the square root of t squared plus 1 dt. I integrate both sides, and this time I integrate from 0 to 1. Yeah, this time I'm going to integrate from 0 to 1. I think. I may have to reconsider that. So Q at 1 is going to be, okay, what is that going to be? And so I'm going to do my guessing thing again. I'm going to guess I'm in the form t squared plus 1 to the 3/2. And when I take that derivative, I get 3/2 square root of t squared plus 1 times 2t. The 2's go away. I need a 3 here. I need a 1/3 on the outside. So it's going to be 1/3 t squared plus 1 to the 3/2. At that point, I know I'm not integrating between 0 and 1 anymore. Because if I did, t at 0 would not be 0, and it has to be 0 plus c, some constant of integration. I'm going to change that to a t. Okay, so q at 0 is 0, which is 1/2 plus c, implying c is equal to minus 1/2. Okay, so q at t is going to be 1/2 t squared plus 1 raised to the 3/2 minus 1/2. And t at 1, t at 1. Okay, so q at 1 is going to be 1/2 times 1 squared is 1, that's a 2. I have 2, the square root of 3 minus 1/2. So that'd be the square root of 3 minus 1/2. Square root of, thank you very much, calculator, square root of 3 minus 0.5. It looks like 1.23 coulombs. Now someone can look in the back and see if I got it right. Assuming that we did, we'll go on to the next problem. Number 22. So I get one right? That's 21.
No.
What does it say?
2 square root 2 minus 1 divided by 3.
That could be the same answer. Alright, I guess I have to look at it. Huh?
It does give 2 answers.
It gives 2 answers? No, it can't give 2 answers. So we're in 24. Number 21. That's pretty weird. How could you have two answers at time t?
It's just two. It's the same answer, it's just two.
It's the same answer, right? Those are the same answers. Now the issue is, don't I have that answer? That's the other issue. Don't I have that answer? Okay. The problem is, I do have the same answer. See this 3 right here and that 3 right there? That 3 right there became a 2 down here. So this is really a 3. That's really a 3. This is really minus a third. That's minus a third. This is a 3. That's a 3. That's minus a third. And now I've got 2. And this is 1 and 1 is 2, right? So that's really 2. So that's the square root of 2 minus 1 over 3, which is the same answer, right? 24, 2. Square root. So I had the same answer, except for a minor insignificant problem of not being able to write down call that a 3 when I came down there, and that hosed me over. All right, well, that's good. Now we have to do number 22, and then we're done with this guy. Well, that was pretty close. Almost pretty close. 22. The current in a circuit is given by I of t equals t to the 3 halves plus 4t. Find the charge in coulombs that passes a given point after 4 seconds. Okay, so Q at 0 is 0. dq dt is I. dq is t to the 3 halves plus 4t dt. Integrate both sides. Q at times t. Is it confusing that I go from capital Q to little q, or do you care? No, you don't care? All right. It's going to be t to the 5 halves divided by 5 halves plus 2t squared plus c. Q at 0 is 0, meaning c is going to be 0, since Q is 0, T is 0. T at 0, Q is 0, implying C is 0. So Q at T is going to be invert and multiply 2/5 T to the 5 halves plus 2t squared, and we want Q at 4 seconds. Okay, so that's going to be 2/5 4 to the 5 halves plus 2/4 squared. 2/5. Now, the square root of 2 is 2. 2 to the 5th is 32, right? 32 plus 16 times 2 is 32. So it looks like I'm going to have 7/5 of 32. 7/5 of 32. And this is an even one, so of course I got it right. 7/5 times nothing. 7/5 times 32. Boom. 48.8. 44.8 coulombs. Okay, good enough. Going on to section 24.3. In 24.3, we're finding the area under a curve. And all we're going to do is integrate between points. Okay, so that's what we're going to do. We're going to start with number 2. 24.3, number 2. And we have y is equal to 5x. From x is equal to 1 to x is equal to 4. And so I draw a picture, and at 1 I'm going to be at 5. 2, 3, 4. At 4 I'm going to be at 20. So we want the area under that curve like that. Okay, so obviously we're going to have 3 times 5, 15, plus 1/2 the base times the height, 1/2 the base, which is 3, times the height, which is 15. So when we get done, our answer had very best be 15 plus 0.5 times 3 times 15. So we better get 37.5 or we're not going to be happy. 37.5. So that had better be my answer. Okay, now we can't do that because this is section 24. So what we need to do is take the integral from 1 to 4 of 5x dx. Okay, so that's what we're doing. And so we're going to go and take, there's going to be 5x squared over 2 evaluated at 1 and 4. Way to go. Alright, so that's going to be 5 times 4 squared divided by 2 minus 5 times 1 squared divided by 2. Okay, so that's 16 times 5 is 16 times 5 is 80 divided by 2 is 40 minus 5 halves. 40 minus 5 halves is 37.5. Is that what we're looking for? 37.5. Lucky guess. Alright, moving on to number 4. 14. Number 14. Okay, y 16 minus x squared. And we're going to go x from minus 2 to x is 2. Okay, so I look at this thing. When x is 0, y is 16. When x is 4 or minus 4, y is 0. So my curve looks like that. And what I want to find is between 2 and minus 2. So I want to find the area in that interval. Okay, so I'm just going to go integral minus 2 to 2 of 16 minus x squared dx. Now, I can do this in this calculator, so I will do it in this calculator first, and then I'll write it down, and then I'll do it manually second. So, second function, the integral from minus 2 to plus 2 of 16 minus x squared. And my answer is 58 1/3. Okay, so that's what I got using my calculator. Okay, now we're going to do the integral thingy, and we're going to get 16x minus x cubed over 3 evaluated at -2 and 2. Okay, so we're going to have 16 times 2 minus 8/3 minus a minus, well, 16 times -2 plus 8/3. Okay, so I've got 32 and 32 for 64. And then I've got -8/3 for -16/3. Okay, so 64 minus 16/3 is 58 2/3. Is that what I said it was going to be? 1/3. I must have fat fingered a key. Do it again. No, it's already in my calculator. I don't have to do it again. It is 2/3 in the calculator. Just can't read it. 14. Are you almost ready to go home? Almost? Think I can drag this problem out for 50 minutes?
Sure.
It's an even one, so you can't even tell if I got it right? All right. Number 30. Find the area bounded by the curve and the x-axis. Okay, so y is 9x squared minus x to the 4th. Okay, so when x is 0, y is 0. So I'm going to have a spot there. When x is 9, y is 0. So it looks like I have something that looks like that. Is that what you think I have?
Makes sense.
Something that looks like that? Actually, it's 3. It's not 9. When x is 3, because 3 to the 4th and 9 times 3 squared is 0. So I think that's the curve I'm looking at. If I factor this guy, I've got x squared 9 minus x to the squared. Yeah, and that would just send it up higher in the positive interval. What's happening over here, I wonder? As x goes negative, it just keeps on, when x is negative, it just keeps going more negative, because that's going to be, no, something's funny is happening over on this side. Okay, when x is -3, when x is -3, this is 0. So it looks to me like I have something like that. And then when I get above -3, it keeps on going more positive. No, that's not going to happen. Is it doing this? It's doing that. Yeah, okay. it's doing this. And then I go more negative. Over here I go more negative. So what do we call this curve? Do we call what that curve's called? Andy remembers. Huh? It's the May-West curve. Guys, I mean, really. When you look at fission products have a curve that, a nuclear explosion have a curve that looks like that. This is xenon 140, and this is strontium 90. And my fission products have it as a distribution that looks like that. And it's called, when we discovered that during World War II, so it was okay to call it a May-West curve. Today, it might not be called that. You might have to call it something else today. Political correctness or something. You don't know who Mae West is. You know Fields, the comedian. What was Fields' first name? The guy that talks really funny in the 30s. Anyway, his sidekick was Mae West. And anyway, enough of that. I knew we could drag this out for an hour because there'd be something you didn't understand. So we'll come back to here. So that's what we're looking at. Okay, so I'm going to do an integral from minus 3 to 3 of 9x squared minus x to the 4th dx. Okay, so that's my plan, based on my brilliant explanation of what the curve should look like. So this is going to be 9x cubed divided by 3 minus x to the 5th divided by 5, evaluated at minus 3 and 3. Okay, so I'm going to have 9 times 3 cubed divided by 3 times 9, right? Minus 3 to the 5th divided by 5 minus 9 times minus 9 minus plus, because I'm minus there, plus 3 to the 5th over 5. Okay, so I got 81 plus 81 is 162 minus 3 to the 5th. 3 to the 5th. Yeah, I don't know what 3 to the 5th is. 81 times, okay, well, we'll just put it in here. 3 raised to the 5th minus 243 over 5. Okay, so 162 minus 243 divided by 5 equals 113.4. So we'll come back to the original problem and just enter it in our calculator to see if we get the same thing. Second function, integrate from minus 3 to positive 3, the function 9 times x squared. Oh, bummer. Second function, integral. Minus 3 to positive 3 of 9 x squared minus x to the 4th, boom. And the calculator says 64.8. Did I get 64.8? Oh, doesn't that just torque you right off? minus 9x squared minus a. So this should be 64.8, and it looks like I've got something else. All right, so what did I do wrong? 9x cubed divided by 3 minus x to the 5th divided by 5. 3 cubed divided by 3 is 9, right? This guy is right. Minus this guy, the quantity, so this is a minus. That's got to be the same thing. That has to be a plus. That has to be the same thing. I think I see the problem. I have 2 of these guys. Do I not? 162 minus 2 times 243 divided by 5 equals 64.8. There we go. 64.8. Thus ends chapter 24 through section 1.